Okay, so we're just doing a video on surface area of prisms, and the shapes we're going to be looking at are cubes, rectangular prisms, which are also called cuboids, cylinders and triangular prisms. Shapes like pyramids and cones and spheres we won't be covering because they're not prisms, because the shape is not constant all the way through. So we're not going to be covering those shapes. Okay, so moving on. So we've got a cube. The dimensions of a cube are the same all the way around. So each of those faces is length times length, which we say length squared, and there are 6 of those faces. So the surface area is 6 length squared. For the cuboid, each of the faces are rectangles. So for instance, that rectangle there would be length times height, and around the whole shape there's going to be 6 faces, but they're going to pair up. So this face here, length height, is going to be the same as the back. And this face here, which is the width height, will have another partner. So each of them has a partner. So we have 2 lots of length width, length height, and width height. And when we do an example, you'll see how those numbers go together. Okay, copy and move across. Okay, the cylinder has a circle at the top and a circle at the bottom. So we have 2 circles. Each circle is pi r squared. And then this curved part, when you open it up, the distance around the outside is the circumference, which is the 2 pi r of a circle, and then we're timesing by height. So that's a rectangle. So the curved part is 2 pi r h. So this part here is called the curved part, and this is the top and bottom. And there's a shorter way of using the formula, which is just to take out the common factors of 2 pi r from both of these numbers, and you're left with r plus h. So this is a really quick way of using it, or you can just use the first one. And the last one, which is the harder one, is a triangular prism. Okay, so we have a triangle at the front, and we have a triangle at the back, and each of the triangles is base times height over 2, but because we've got 2 of them, a front and a back, we can cancel out the 2's, so you're just left with base times height, and that gives you the 2 triangles. Okay, and then every other face around the outside is a rectangle, which will be multiplied by the length. So it's just the length times the 3 sides added together. Now I've called this side the base, but we could say it's a side 3, but I'll call it the base. Okay, so copy that and come across. Okay, so we'll look at some examples, straightforward ones. Okay, so we've got a cube because we've got the 3 lines. So the surface area equals to 6 times 4 squared. 4 squared is 16, so the answer is 96, and the unit of area is a square units. Okay, for the rectangular prism, we have 2 lots of it, and what we do is we just pair them up. So we've got 5 times 2, and then we go 2 times 3, and then we go 5 times 3. Okay, so we've got 2, and again, you just do this on your calculator. I'll just do it the long way. So we've got 16, 31. So the answer is 62. And again, square units for area. Okay, so copy that and come across if you need to. Okay, so here we've got a cylinder, but here, this time I've given you the diameter. Okay, so the surface area is 2 pi r plus h. So it's 2 times pi times 3 times 3 plus 10. Now I have to use my calculator because we'll use pi as the proper pi in your calculator. So 2 times pi times 3 times 13. And so that equals 245.004 if you're going to go 2 decimal places, meters squared. Okay, triangular prism. We're missing this side, but we've got a right angle triangle. And so this is the hypotenuse. So hypotenuse squared equals 6 squared plus 8 squared. Again, you might recognize it as a Pythagorean triad because the height, that distance there is 10 for the hypotenuse. Okay, so the surface area is base times height plus the length times 8 plus 6 plus 10 to the 3 sides. So again, just use your calculator. I'll do it the long way. So 1424. You'll use your calculator. That's 120. That's 120. So I've got 168 metres squared. Okay, so copy that and come across. Okay, so the ones that are more interesting are the composite shapes, where you have to use bits of each formula. With this one here, for instance, you've got two rectangular prisms, and again, I'm not going to be doing it because I'm not going to put numbers on, but this face here is missing from both of those. It's missing from this shape and it's missing from this. And so for that one, you just do two rectangular prism formulas minus 2 times the hidden shape, because it's hidden from both shapes. So this side here, this dimension here, that rectangle will be the rectangle that's missing, but it's missing from both. For instance, with this one here, you've got a bit of a circle at the top and a bit of a circle at the bottom. So this part here would be, like that surface area would be pi, the big radius squared, minus pi, the little radius squared, and that will give you that donut-y shape. And then you have to double that because there's one in the bottom. And then you just add the inner curve part, and you add the outer curve part. Okay, so there's a curve part on the outside and there's a curve part on the inside. And so then you would just use the 2 pi RH of each of the shapes. So 2 pi radius 1, 2 pi radius 2. Okay, so you've got the donut shape at the top, which would be just 2 circles subtracted, and then you double it, and then you've got an inside curve shape on the inside and an outside. So there'll be some ones in the book to practice for those ones. Here you've got a half of a cylinder, and you're adding it to a rectangular prism. But then you've got to think about what shapes are hidden. Like, for instance, that top shape on the rectangular prism you won't see, and you've only got half of a cylinder. So you just use half of the cylinder formula. Okay, so that's, so instead of having 2 pi r plus h, you just have half of 2, so you just have pi r plus h, because you've got everything's still there. You've got half of the curve and you've got half of the circles, so it just end up being pi r plus h. So see if there's any ones in the book that look like that, and that's the end of the video. So practice those ones, especially the understanding type questions where you have to apply the surface area to other types of questions. Thanks.